Exercise 8.3, Problem 7, Discussion. Let's read the problem. A right circular conical vessel whose internal radius is 5 cm and height is 24 cm is full of water. The water is emptied into an empty cylindrical vessel with internal radius 10 cm. Find the height of the water level in the cylindrical vessel. Okay, that's an interesting problem. Let's mark what is given here. A conical vessel, internal radius is 5 cm and height is 24 cm. It's full of water. Okay, this water is emptied into a cylindrical vessel with an internal radius of 10 cm. Okay, the key which you have to understand is that there is water in a conical vessel and that is transferred to a cylindrical vessel. Okay, now what is the key? Whatever water is in the cone is going to get transferred into the cylinder. Okay, that's the key point which you need to understand. So, radius of the cone is given 5 cm, height of the cone is given 24 cm, radius of the cylinder is given capital R, that is 10 cm. We just need to differentiate this because radius is there for cone as well as for cylinder. So, for cylinder it is capital R and height is capital H. Whereas for cone it is small r and small h. Okay, so this is given. Next, let's find out what is asked. We are asked to find the height of the water level in the cylinder. Height of the water level in the cylinder is what they are asking us to calculate. Okay, so key is the volume of water in cylinder equal to volume of water in cone. It's just getting transferred from cone to cylinder. So whatever water is in the cylinder is going to get transferred to the cone. So what is volume of a cylinder? Pi capital R square H. Okay, what's the volume of a cone? 1/3 pi small r squared H. So these two are equal. And as you can see, the radius of the cone is given 5 cm. Height of the cone is given 24 cm. Radius of the cylinder capital R is given 10 cm. So which means only H is not known. So using this equation, we will be able to calculate the height of the water in the cylinder. Okay, very simple. So let me summarize the steps. Let H be the water level in the cylinder. Equate the volume of the cylinder to the volume of the cone. As we discussed, if the water is just getting transferred, so volume of the cylinder equal to volume of the cone. So pi r squared H equal to 1/3 pi r squared H, and calculate height. So that is it. It is pretty easy, though it looked little difficult. The moment you break it, you will be able to easily understand. The key is you need to keep this in mind. Reshaping, refilling, all these things, the volume remains constant. Okay, so pause the video here and try to work this problem on your own, and after working, come back and check you are working with our solution. Okay, the solution. The radius of the cone is 5 cm, height of the cone is 24 cm, radius of the cylinder capital R is 10 cm. So let H be the height of the water level in the cylinder. Since water is transferred from cylinder to cone, the volume of water in the cylinder equal to volume of the water in cone. So when you equate this, pi r squared H, that is capital R, capital H refers to cylinder, equal to 1/3 pi small r squared small h. This is cone. Okay, we have given here for the cone it is small r and small h, for cylinder it is capital R and capital H. Okay, so substituting all these values, you should be able to get the value of H because there is only one unknown here. So pi into capital R is 10 cm. So 10 into 10 into H equal to 1/3 into pi small r, that is 5. 5 into 5 into small h, that is 24. Okay, so this on simplification you will get pi and pi will get cancelled. Okay, and so it will become 5 into 5 into 24 divided by 3, and these two tens will come down. 10 into 10. So this 10 tens are 100, 5 5s are 25, 25 will go 4 times, 4 3s are 12, 12 will go in 24 2 times. So the height is 2 cm. So the height of the water level in cylindrical vessel will be equal to 2 centimeter. So only up till that level it will get filled up. Okay. So I hope you got the problem done correctly, and if not, please check where you have gone wrong and make suitable corrections. If you have not understood the concept, please go back to the discussion part of the video and try to understand the concept clearly. Thank you for watching the video.